Dear all, it is nice to talk to you again in 2023 Hikrobot Machine Vision New Product Launch event. This is Sean, Product Marketing Director. Today we will share with you our latest product and technologies. Please enjoy. 2022 was a tough year. The industry had experienced a chip shortage, longer lead time, consumer market shrink, and requirement decline, etc. And the pandemic still kept affecting the world, blocking the free movement between countries. Hikrobot took the challenges, worked hard, and achieved a rapid growth again in 2022. We, Hikrobot, position ourselves as a product provider, from industry cameras to smart cameras to algorithm software. Hikrobot machine vision products help you improve work efficiency and accuracy, reshaping your productivity in the era of smart manufacturing. This year, we have enhanced our portfolios in all three key product lines. For standard line, we are expanding our high-speed series with more resolution from 4 megapixel, 5 megapixel, 12 megapixel, 21 megapixel, and 25 megapixel to 65 megapixel with camera link and co-express interfaces. For line scan series, we have developed 2K, 4K, 8K, and 16K 4 series. We also cover the frame grabbers in GigaE, 10 GigaE, USB 3, camera link, and co-express all interfaces. And we are improving our lens and lighting product lines to make a better image acquisition system. For smart and ID line, we reach our ID solutions from fixed to handheld as well, and greatly strengthen the read rate of extreme DPM code by using deep learning. We also enhanced our vision master structure and algorithm, making it more advanced both in efficiency and accuracy. For 3D line product line, we released the DP2000 and DP3000 series and multiple RGB-D cameras for various applications. This year, we are expanding our business into more countries and serve more customers from different industries like Li battery, automotive, medication, logistics, and many more. We established our new offices in Korea, and we set up more branches across the world to better support our valued customers from local. Customers' benefit is always our top motto. We aim to offer best possible products and service to our customers. We are working on these fields to achieve it. First, better performance. We have breakthrough success in high-speed interface transmission technology. With this technology, we are able to transmit huge data much faster with less cost. We also optimize real-time performance and develop more rich ISP function for our cameras. And the quality is always our basis of value. We emphasize quality in all aspects of our business and not stopping improving it. Second, stronger algorithm. We continuously improve our algorithm efficiency and performance by developing richer and more accurate operators, and combine deep learning with traditional pattern matching solution. By doing this, we are able to utilize the advantage from both sides and make the best solution for our customers. And the third, ease of use. From hardware side, we made a more integrated design and developed richer accessories to fit for more scenarios. For software side, we set up guided configuration and modular designs to reduce learning curve for our users. Hikrobot will keep eye on the better quality from our product and solution, and we will also try our best to ensure your vision solution a best one ever. Here comes the new product release session. Next, please welcome my colleague Yi. She will give you more details about our standard product family. Thank you.
Thank you, Sean. This is Yi from the standard product line. Last year, we have talked about how to build a superior image acquisition system, focusing on the camera technology and innovation of the frame grabber. This year, I want to introduce our advanced technology and let high-speed wetness wonderful. First off, let me just give you a quick rundown of our standard product line. We've got 6 main categories, including area scan cameras, line scan cameras, frame grabber, lenses, lighting, and accessories. And get this, we've got about 900 different models to choose from, divided into 30 plus different product series. And that means we've got you covered for just about any inspection requirements you might have in the machine vision industry. And so far, I am proud to say that we've already served more than 7,000 customers worldwide. As technology keeps advancing, industries like semiconductor, printed circuit board, lithium battery, and printing are all expecting greater efficiencies and speed from their production processes. So how can we step up to meet those demands? We're expanding our product line of high-speed products this year and bringing you more options with our growing selection of high-speed cameras and frame grabbers. Let's first check out this chart. The Co-Express protocol is like the MVP of machine vision interfaces regarding speed. And if you look at this chart, you can see that when you are using 4 channels of CXP12, it can give you a maximum bandwidth of 40 gigabit per second. And that makes it perfect for high-speed applications. So if we use this protocol as the interface for our cameras, we've got a much better chance at getting those high frame rates everyone's looking for. So with this interface in mind, we're releasing a brand new 12 megapixel resolution area scan camera this year. And we're actually offering 2 versions of this camera. One with the CXP6 data interface and another one with the CXP12 data interface. The maximum frame rates are 180 and 330 frames per second, respectively. And to keep that high-speed performance going strong, we will provide fanless structure for these models, ensuring a steady acquisition and no disruption from fan vibration even in high-speed applications. Coming up next, we've got some serious high-speed small-sized action with 2 new cameras featuring resolution of 25 and 65 megapixels. Now, we've already had some popular camera at these resolution levels with 10 gig and Co-Express data interfaces. And this year, we are upgrading both of these cameras with a new design in order to accommodate installation of small spaces. And with dimensions of 50 times 50 times 45 and 70 times 70 times 45, these cameras are more compact than ever before. And the frame rates of these cameras are 41.5 and 71 frames per second, respectively. And of course, we also prepared the CXP interface frame grabbers for those cameras. These frame grabbers support CXP6 and CXP12 data interfaces and can handle up to 20 gigabit per second or 40 gigabit per second of bandwidth, depending on the model. Not only that, but they also have 8 I/O interfaces that can be configured for easy communication with other devices outside of the acquisition system. And the topology between the frame grabber and the camera is extremely flexible, allowing for different configurations depending on your frame rate requirements. You can use one camera with one frame grabber to achieve maximum bandwidth. Or if you don't need high frame rates, you can use 4 cameras with one link to synchronize image acquisition with the same frame grabber. On the other hand, you can use 2 cameras with 2 links to capture images with just one frame grabber. It all depends on what you need for your specific application. Now, earlier we talked about the Co-Express data interface with its high bandwidth capabilities, which is perfect for high-speed applications. However, the data cost can be a little bit high. And that is why we are so excited to introduce our X over Fiber interface from Hikrobot. We hope that this new interface will better serve our customers for great balance between bandwidth and data cost. Now, you might be curious, What is X over fiber? The second half of the name is pretty self-explanatory, indicating that this interface uses fiber as the transmission medium. But what about the X? Well, in this case, the X represents high-speed interface protocols such as 10GbE, CLHS, Co-Express, and even higher speed protocols in the future. And by using X over fiber, we can standardize both the transmission medium and the form of frame grabber, making it much easier for customers to choose the compatible product. Besides its cost advantages, X over fiber also offers several technical benefits. As we can see, the typical high-speed interfaces like 10GbE, CLHS, and Co-Express, they offer similar bandwidth when using one copper and fiber as the transmission medium. However, since fiber optic links are easily aggregated, we can obtain a 7 or even 8 lane of fiber, providing us with even higher transmission bandwidth. And moreover, using the X over fiber interface allows for a significant increase in uplink bandwidth. With greater uplink bandwidth, enumerating and connecting cameras can be done more quickly, and commands can be issued with faster response times. Now, ultimately, this results in a more fluent user experience for high-speed applications. Taking a different approach, high-speed cameras are usually paired with frame grabber. The frame grabber receives a trigger signal and communicates it to the camera through the transmission link. X over fiber optimizes this process even further than any other protocols on the market, achieving a real-time response rate as fast as 0.2 microseconds. Now, I would like to introduce several camera products that use the X over fiber interface. The first one is our 21 megapixel high-speed area scan camera. We already have a 21 megapixel camera with CXP12 interface that can achieve a maximum frame rate of 222 frames per second. This year, the X over fiber interface camera can support a bandwidth of up to 100 gigabit per second, allowing for even higher frame rates of 500 frames per second. It also supports ROI and binning to further increase the frame rate. And a high-speed camera like this is primarily used in industries that demand super fast speed, such as 3D SPI and 3D AOI applications in SMT. Moving on, I'd like to introduce the second X over fiber camera product, which is an 8K resolution line scan camera with a 7 micrometer pixel size. It is equipped with a dual link to achieve a total bandwidth of 20 gigabit per second. In addition, we will also release two models: a monochrome model with a line rate of 200 kilohertz, as well as a color model with 66.6 kilohertz in RGB pixel format. For the monochrome model, the camera can capture brighter images with the TDI function. This camera supports 2 TDI mode, which will provide images with doubled brightness, meaning that the entire system will have a lower requirement for the light source. And our new color model features a 3-line true color sensor. Compared to conventional Bayer sensors, the true color camera delivers better color representation, as you can see from the comparison of the two images above. With greater and sharper edge details, this camera provides a more realistic image. And compared to 8K 5 micrometer pixel cameras in the market, our new 8K line scan camera, featuring a 7 micrometer sensor, delivers even better image quality. In one-line mode, there is already a noticeable increase in brightness, but when coupled with TDI mode, the image brightness shows even more significant advantages. In recent years, we have observed an increasing demand for higher imaging consistency among multiple cameras in many line scan camera applications. Therefore, in the manufacturing process of our 8K line scan cameras, we have made improvements by introducing high-precision sensor alignment technology and implementing strict controls on sensor installation. Now, we have achieved higher accuracy in rear focal adjustment, rotation, and translation to ensure imaging consistency. Thanks to its high line rate, sensitivity, and true color capabilities, this camera is an excellent choice for inspecting webs on fast-moving production lines, such as printing materials, lithium battery, and other similar inspection applications. The second line scan camera we have for you is a 16K true color high-speed line scan camera. It employs a 2-link X-over-fiber interface and can deliver a maximum line rate of 47 kHz in RGB pixel format. Furthermore, it also features 2 TDI mode. Compared to the previous 16K camera with 3.5 micrometer pixels, this new camera has a larger pixel size of 5 micrometer, which makes it more responsive and sensitive. Under the same lighting conditions, the images with 2 TDI mode shows noticeable increase in image brightness. And the camera is also integrated with a rich set of ISP algorithms, including purple edge correction and a super palette, which lead to better color reproduction in general. In PCB AOI inspections, high color rendition, image accuracy, and fast speed are critical requirements. Additionally, as inspection precision requirements continue to rise, the bottleneck of using 8K cameras for image stitching becomes more apparent, and it's time to upgrade to 16 camera. And this product is an exceptional fit for these applications. Next up is our final new product of this year's line scan camera, and also the first product from Hikrobot that supports advanced 257 TDI, the 4K high-speed line scan camera. This one is equipped with 5 micrometer pixel size sensor and can achieve a maximum line rate of 250 kHz. Advanced TDI is just like the 2 TDI we introduced earlier, can improve image brightness. However, the 256 TDI takes it a step further for scenarios where the images are very dark, like in medical eye exams using OCT. In these situations, it is difficult to get enough light, and a normal TDI just doesn't do the trick. But with 256 TDI, the overall brightness of the image is greatly improved, especially for critical areas that need clear detection. And this camera also supports dual mode, switching between area and TDI. In line scan camera applications, capturing a complete object requires relative motion between the object and the camera, which can be challenging to perform position calibration during camera installation. To address this, we have developed the area mode for this camera, which means the camera can be used as an area scan camera and output a 4K times 256 resolution images. This image can show the object locating points easily, even when there is no relative motion. Once calibration is complete, the camera can then be switched to TDI mode for normal image acquisition. The primary application of this camera are flat panel display inspection, semiconductor wafer AOI, and ophthalmology examination. Beforehand, we presented camera products associated with X-over-fiber interface. And now we're so thrilled to introduce the X-over-fiber frame grabber. This frame grabber can be used together with the camera products we mentioned earlier, and its dual-port design allows for a maximum data bandwidth of 20 gigabit per second. In addition, this frame grabber is equipped with an FPGA, which eliminates the possibility of data packet loss. Moreover, several ISP algorithms like Bayer interpolation, color correction matrix now are supported on the frame grabber. And that can free up the FPGA logic resources on the camera and the CPU resource on the PC. And meanwhile, the frame grabber also comes with 24 I/O interfaces that can be flexibly connected to external devices. And also signal synchronization between two frame grabbers are achievable. And what's more, surprisingly, this frame grabber can be used as a signal generator, outputting signals as user preset waveforms to trigger other devices. In addition to this frame grabber, we spent a year after launching the frame grabber series last year, continuously expanding and optimizing our product series. Currently, we have a very wide range of frame grabber series. We offer frame grabber with GigE, 10 GigE, USB, camera link, co-express, and X-over-fiber interfaces. For this series, we have made improvements in usability. We will release a toolkit to enhance the user experience. The toolkit consists of a variety of diagnostic tools. The first one is a PCIe diagnostic tool, which supports exporting the current status of the frame grabber to help monitor and troubleshoot the PCIe bus. The second one is a device diagnostic tool, which allows for monitoring of the frame grabber status. This includes monitoring I/O status and waveform changes, events received by the frame grabber, and the device running logs produced during use. The third one is a PC diagnostic tool, which enables detection of PC environment variables and the dynamic libraries that the frame grabber relies on. It also supports fast repair for the operating environment, making it easy and simple to use. Finally, I'd like to show you the mass production schedule for our newly released products today. Okay, so that's all for the content brought to you by the standard product line. Thank you. Next, let's welcome Spencer from the Smart ID product line for more product info.
Thanks, EE. Greetings to everyone. I'm Spencer from Smart ID product line. The topic this year is Be Faster, Be Smarter. I will introduce to you the work we have done to improve software efficiency, as well as the new hardware products to be launched. Last year, we released the VM 4.2. VM is a machine vision algorithms platform independently developed by Hikrobot, which includes more than 140 algorithm tools. The flowchart configuration way and graphical user interface make vision applications easier. In recent years, as machine vision applications have rapidly spread, more and more developers have chosen to use generic and tool-based development platforms to complete visual application development, which can greatly improve the efficiency of visual projects. However, in this process, developers also find that when visual solutions are complex with multiple vision modules, issues such as resource consumption, operation frequency, and software processing time often become pain points of the application. Therefore, in response to these pain points, over the past year, the VM R&D team has deepened optimization and improvement from software strategy, underlying operator design, and the image algorithm principles to significantly improve the efficiency and the user experience of the VM, as well as largely reduce software resource consumption. We have released VM 4.3, and today I will give you a detailed introduction to the specific updates of this version. Firstly, in the software layer, we optimize the memory allocation, CPU resource utilization, and the operation system adaptation. We all know that memory operations are very frequent in visual software, so it is extremely important to reduce memory allocation time and increase memory utilization. In terms of memory allocation mechanism, VM 4.3 fully utilizes the characteristics of memory pool and CPU, and pre-allocates memory blocks of unequal quantities and size, according to the memory size of the pool and the frequency of application. Then, the software uses them as needed, which can improve memory allocation, data transmission efficiency, and memory usage. In terms of CPU resource utilization, it fully takes the advantages of the new generation of CPU architecture and puts the intensive calculations in the CPU's core graphics, thereby reducing CPU utilization while improving software efficiency. In terms of resource loading, we adapt to the operation system's data processing characteristics, use the time difference between the software operations, and use on-demand and asynchronous data loading to speed up software starting and solution loading. After optimization, the newly released VM 4.3 has made significant improvements in memory usage, multiprocess efficiency, interface rendering, solution loading, and data transmission for secondary development. The software runs faster, consumes less resources, and is smoother in overall use. At the algorithm level, starting from the principle, we optimize the key nodes that affect the time consumption, taking several typical algorithms as examples. Template matching is one of the most representative algorithms in machine vision. It extracts several feature vectors from the template image to establish a template. Then, through a specific search algorithm, it extracts the same features from the image to be searched, calculates the distance between the image features and the template feature vectors, and determines whether the target area is the search area by the minimum distance method. From the principle, we can know that there are mainly two parts that affect the template matching time consumption. One is the image feature extraction and the calculation of the similarity between the image and the template, which can be regarded as single-time cost. The other is the number of searches. Therefore, to put it simply, reducing the single search time consumption and the number of searches are the most effective means to improve the matching algorithm efficiency. We optimized these two parts separately. First, to reduce the single match time, the core is to choose the most suitable feature points. These feature points should not only reflect the characteristics of the template, but also have a reasonable quantity, and should avoid being in the background or interference areas as much as possible. VM 4.3 adaptively selects edge thresholds, feature tree steps, and the pyramid levels based on the characteristics of the template image to extract the most suitable feature patterns, as shown in the figure. Secondly, in the matching process, a reasonable search strategy can greatly reduce the time of matches. Unlike traditional algorithms that use layered pyramid search, VM 4.3 uses variable pyramid levels and adaptively search step methods to quickly focus on the target area, greatly reducing the number of matches while ensuring accurate results. After optimization, the matching algorithm in VM 4.3 has a clear advantage in terms of efficiency compared to mainstream software on the market. Of course, there is a large improvement compared to VM 4.2. Let's move to the blob analysis algorithm, which usually includes 3 steps. The binarization process is relatively simple, and the main time-consuming part is the connected area analysis and the feature calculation and filtering. In order to speed up, we improved the connected area search algorithm, changing the traditional fixed step to a variable one by calculating based on the image features. In addition, after obtaining the connected area, when getting the features, we adjusted the calculation method and order according to the relevance of the features, eliminating ineffective and repeated calculations in traditional algorithms, achieving the goal of acceleration. The optimized blob analysis has been improved in terms of time consumption and resource utilization, especially in large resolution images and large target scenes. For example, take the 8K times 12K resolution image, for example. It contains around 80,000 connected areas, and it will only take around 80 milliseconds for blob analysis. By adapting cache size blocks, deep coding, instruction sets, and assembly optimization, most algorithms in VM 4.3 also have a significant efficiency improvement. In addition to algorithm efficiency, VM 4.3 has made many improvements in algorithm memory usage. By improving code implementation, operator encapsulation, and other methods, we have reduced the memory usage and redundancy, improved the memory reuse rates, and resource utilization. The memory consumption of most algorithms is significantly lower than that in VM 4.2. Continuous improvement of performance and expansion of tools are important contents of each upgrade of the VM, and VM 4.3 is no exception. For example, in the template matching tool, by extracting more robust feature points in the modeling stage, the feature quality is improved. In addition, a more flexible target screening strategy is adopted in the matching stage, and the performance of the template matching is further improved, especially in complex situations, such as low contrast and strong interference. The recall rate and accuracy are improved to some extent. We use several practical scenario cases to show the matching effect of VM 4.3. In the low contrast situation shown in the figure, since the pattern features have little difference from the background, most other software on the market cannot successfully match the target. But VM 4.3 can effectively match it. In the edge interference scene shown in the figure, although general software can match it, there is a significant edge deviation during matching due to the interference of shadows, resulting in a larger matching error. From the enlarged details, it can be seen that VM 4.3 can achieve precise positioning. Similarly, in challenging scenarios such as small targets and strong interference, VM 4.3 can also accurately match the target with stronger scene adaptability. Defect detection has always been a difficult point in machine vision. To meet the changing application needs, VM 4.3 has added surface defect detection algorithms that can detect scratches, spots, and cracks in complex surfaces. In addition, we have developed an online register and classify algorithm for applications such as positive, negative, presence, absence, and multi-classification. This algorithm can achieve fast and accurate detection and classification without offline training by registering only a few sample images. The register and classify algorithm is simple to use and does not require complex procedures or parameter designs. All that is needed is to register the types that need to be detected. Therefore, the register and classify algorithm is especially suitable for frequent retrieving, where it can be quickly deployed. In recent years, deep learning algorithms have been increasingly used in defect detection, especially those based on semantic segmentation algorithms. Therefore, we have also optimized it in VM 4.3, resulting in an average detection rate increase of more than 15%. This increase is particularly noticeable in the detection accuracy and rate of small defects on large resolution images. Apart from the algorithms mentioned, the performance of geometric search, text recognition, object detection, calibration, and others in VM 4.3 also has been improved to varying degrees. In addition to the continuous enrichment and improvement of algorithms, VM 4.3 has also added many new features. For example, in response to the needs for convenience and solution privacy in software maintenance on project sites, VM 4.3 has added a configuration interface that extracts commonly used parameters and configurations into a single interface and groups them as needed. The comprehensive configuration interface enables modifications to module ROI, operating parameters, and judgment conditions without opening the solution process, greatly improving the convenience of the application. Furthermore, VM 4.3 has added functions such as ellipse search, dual view configuration, matrix circle search, parameter effects in real time, and etc. And it optimizes and improves rendering efficiency to make VM more adaptable to diverse application demands. Let's move to the hardware part. The ID product family has been continuously developed over the years, covering logistics, industry, handheld, and module series. Its performance also has been approved by our industry partners. We have never stopped innovating in terms of product and technology. And this year, we've continuously polished and enriched the series. Today, we introduce the flagship product of the ID 3000 series, the ID 3000 XM, which shines in terms of performance, size, and usability. The ID 3000 XM is designed with various forms of status indications, such as top, side, and projected light. The current coding status can be observed easily from different angles, making it adaptable to more installation methods. The small size and rotatable tail cable design makes it easy to install in the compact space. In terms of imaging, the ID 3000 XM uses polarized, diffused, and fully transparent lighting design. The triple optical design enhances the adaptability to complex scenarios and changes on industrial materials. In addition to dozens of existing codes, the ID 3000 XM also supports new codes such as micro QR and pharmacode with richer coding capabilities. In addition to its code reading capabilities, the ID 3000 XM are also compatible with new accessories such as ultra-small code accessory, uniform light cover, ESD and YAD protection covers, which enhance its reading and scene adaptation capabilities. For instance, the ID3000XM, when paired with the ultra-small code accessory, can achieve greater magnification and stronger resolution capabilities, making it easy to identify 2D codes with a minimum unit of 8 micrometer. The integrated installation method can reduce the working distance by 40 millimeter, making it adaptable to more compact device spaces. After installing ultra-small code cover, the ID3000XM provides more uniform illumination, significantly improving code reading rates and stability. The uniform light cover accessory, designed for difficult code applications, can easily eliminate glare, provide multi-angle illumination, and suppress background interference. As shown in the comparison image, pairing with the uniform light cover makes DPM code feature clearer, achieving a higher reading rate for difficult codes in complex environments. The smaller and more powerful ID3000XM is widely applicable in industries such as consumer electronics, lithium battery, tobacco, and medical, providing higher and more stable information collection. Last year, we have launched the handheld code reader, IDH7000, for the first time. Over the past year, we have continued to enrich our handheld code reader product line, developing multiple series, such as IDH7000, 5000, 3000, and 2000, creating a complete product layout to meet the needs of various levels in industrial and enterprise applications. The handheld code reader inherits the excellent reading performance of the fixed industrial code reader, with obvious advantages in recognizing difficult DPM codes, reading efficiency, industrial protocols, and scene adaptability. The IDH7000 and 5000 series are designed for challenging industrial scenarios, with powerful DPM decoding capabilities, excellent recognition abilities for challenging codes, such as metal engraving, through-hole, and soiled codes. The robust structured design, various light supplement methods, and rich communication protocols allow IDH7000 and 5000 to easily cope with the complex and diverse industrial environments. They have already been widely used in the car manufacturing, printed circuit board, lithium batteries, and photovoltaic industries. The IDH3000 is designed for common industrial scenarios. With built-in deep learning code reading algorithms, it is suitable for difficult codes like DPM codes and inkjet anomalies, such as frame breaks, ink spills, ink shortage, bar space ratio anomalies, and marking interference. It uses 1.3 megapixel image resolution with excellent small code reading performance and a minimum reading resolution of 0.8 ppm. It has Ethernet and USB ports, with wired and wireless models selectable, making it the best choice for mobile code reading in industries such as consumer electronics, medical, fast-moving goods packaging, tobacco, and logistics. The IDH2000 is designed for industrial enterprise applications. With lower power consumption and stronger reading capabilities, it can easily address wrinkled 2D codes, poor printed 1D codes, and mobile payment codes. It has high reading efficiency and product durability, capable of withstanding 5 million button presses and 1.5 meter drops. Compared with handheld code readers in the same level on the market, it has obvious performance and quality advantages, making it widely used in parts traceability, product label reading, and warehouse inventory in most manual and semi-manual production lines. In single-camera vision system applications, there is often a choice between smart cameras and PC-based systems. As we all know, smart cameras have great advantages in convenience, system complexity, and ease of operation as an integrated vision system product. However, in machine vision applications, PC-based systems still are majority. The main reason is that smart cameras have significant limitations in computing power and algorithm adaptability, resulting in a large gap between PC-based solutions. As a result, sometimes we have to choose a more complex system with higher cost and greater implementation difficulties, namely the PC-based approach. In order to solve the above obstacles, we have developed the powerful and highly flexible AI smart camera, SC6000 series. First of all, in terms of its computing ability, SC6000 adopts a high-performance embedded platform with strong AI capabilities. This platform has excellent processing performance for both traditional and deep learning algorithms. Some people may argue that there were already many smart cameras with AI processing capabilities before SC6000. However, we can see that these smart cameras were often limited by large power consumption, large size, and restricted applications. SC6000 has been developed and designed with targeted search on power consumption and heat dissipation, allowing for smaller dimension and lower temperature rise. It is only half the volume of the same level product on the market. Unlike traditional smart cameras, which have only a few vision tools, SC6000 comes with the built-in VM algorithm platform with over 140 tools to tackle more complex applications. Additionally, it adopts graphical interaction and flowchart operation, greatly improving the camera's flexibility while maintaining its high usability. In terms of interfaces, to enhance application flexibility and the ability to cope with complex scenes, SC6000 supports C-mount lenses and external light sources, which can be flexibly selected based on the scene requirements, breaking the application limitations of smart cameras. The SC6000 series covers multiple resolutions, including 1.6, 5, and 25 megapixel, and any resolution can be extended according to the application characteristics through image ROI settings. The high computational power and the strong flexibility of the SC6000 AI smart camera can be widely used in positioning, measurement, recognition, and detection in various industries, making it the best choice for single-camera vision systems. We believe that we will see more smart cameras in increasingly diverse scenarios in the future. The proportion of deep learning technology in machine vision is increasing. The application of deep learning projects generally involves multiple aspects, such as sample collection, management and labeling, model training, and on-site deployment. As deep learning applications are widely promoted, the management complexity of deep learning data is increasing, and a larger amount of manpower is required for the mentioned steps. In addition, a strong model training environment cost is also very high. In order to deal with the difficulties, we have integrated the data with the project management. We have developed an AI training platform with a complete deep learning application process and provided multiple deployment methods such as public cloud, private cloud, and a standalone deployment to meet the needs of different application projects. On the AI training platform, project managers can manage and the control members and the permissions according to the project, as well as uniformly manage project data sets and models. In addition, the standalone version of Vision Train and the online version of the AI training platform can achieve data exchange. The AI training platform supports model training for various edge devices such as VM, SD smart cameras, ID code readers, and 3D cameras. The products I introduced today will be gradually released in the next few months. Please pay attention to our product updates. That's pretty much for the Smart ID session today. Thanks for listening. Next, please welcome my colleague David for the 3D product info.
Thanks, Spencer. Hello, everyone. I'm David from 3D Product Line. I'm glad to introduce the new 3D vision products of Hikrobot to you. As everyone knows, in the past few years, the field of machine vision has experienced a rapid development. With the high-quantity vision products and the VM algorithm software, Hikrobot has participated in and witnessed the intelligent upgrading of numerous industries. However, in the field of industrial high-precision measurement, 2D vision cannot solve all problems. The dimensionality upgrade brought by 3D vision provides great help for industry inspection. Next, I will bring you boost high-precision measurement with 3D vision. Hikrobot's 3D vision focuses on two areas: high-precision measurement and robot grasping applications. At last year's new product launch, we introduced the RGB-D product series and the Robot Pilot 3D vision guidance platform software. After continuous refinement, we introduced you the Laser Profiler product series, including the DB2000 and the DB3000 sub-series. The Laser Profiler uses the principle of line laser triangulation to obtain 3D information of the measured object. Firstly, the Laser Profiler projects a fine laser line onto the surface of the object, and the laser line reflects to form a counterline. Then the counterline is imaged through a lens in the sensor component and collected by the laser profiler. Furthermore, the processing unit of sensor calculates and restores the depth information of each point on the laser counterline according to the principle of triangulation. This principle is also referred to as the light sectioning method. When the object moves relative to the laser profiler, each counter of the object along the direction of motion can be sequentially collected and calculated by the sensor, thus dynamically restoring the complete 3D information of the measured object. The characteristics of dynamic scanning and collection during object motion make the laser profiler widely used in online 3D measurement in the production process. A good product must go through careful design and refinement to ensure product quality. Next, I will analyze some of the precise design of our laser profiler. Firstly, the 405 nanometer ultra-uniform and refined blue light ensures accurate extraction of laser counterlines. Secondly, customized large aperture lenses are used, with a light flux equivalent to 4 times that of ordinary lenses, ensure extremely high MTF resolution. Third, a dedicated sensor with high sensitivity and a dynamic range of up to 90 dB is used to ensure excellent image even in extremely complex scenes. Fourth, through sham optic design, achieve clear images throughout the full range. With precise optic adjustment, the laser, lens, and the sensor work together perfectly to ensure high-quality imaging of the laser profiler. Finally, our laser profiler adopts an integrated design with built-in computational power, and the camera is equipped with a high-speed processing unit, enabling a processing speed of up to 19 kHz. To fully utilize the capabilities of laser profiler, powerful algorithm processing is required in addition to the finely designed hardware. For line laser triangulation, the core algorithm is the extraction of a center point of the profile line. A highly robust extraction algorithm enables the sensor to easily handle various complex scenarios. Building upon the center point extraction algorithm, further integration with sub-pixel processing algorithms can improve the extraction accuracy up to 0.05 pixels, thereby enhancing the sensor's Z-axis detection precision. As a standardized industrial product, laser profiler need to deal with 3D data acquisition of various materials. Wide dynamic processing algorithms can adopt different exposure parameters for materials with different reflectivities, and then perform fusion processing, allowing the sensor to simultaneously extract profiles from highly reflective and light-absorbing materials. When dealing with metal surfaces, specular reflection can cause errors in center point extraction, especially for straight light with multiple metal surfaces such as threads and pins. However, anti-reflection algorithms can effectively reduce this impact. The 3D data collected by laser profiler usually requires further post-processing for better algorithm analysis. We have built-in rich post-processing algorithms on the sensor side, including spatial filtering, temporal filtering, point filtering, bidirectional interpolation, edge extension, etc., which are convenient for customers to choose and do not occupy the CPU resource of the host. Our laser profiler adheres to the principle of simplicity and ease of use, providing rich data interface to output profile data, point cloud data, depth maps, and brightness maps. It's also compatible with various trigger modes, supporting differential encoder trigger input, including line trigger, frame trigger, and line plus frame trigger application modes. Through the SDK, our laser profiler can be easily integrated into third-party software framework. We offer 3 language versions of SDK. It's C, C#, and Python, as well as more than 10 integrated simple programs, including mainstream visual analysis software for user secondary development. In addition, in our client software, we have simplified the adjust process of the depth map, supported one-click debugging, and provided an I/O signal monitoring tool to facilitate on-site rapid debugging and deployment. The DB2000 laser profiler series includes 5 different field of view models with 2,048 points per profile. The highest acquisition frequency can reach to 10 kHz, with an x-axis measuring range of 22.2 to 798 mm, z-axis repeatability of 0.4 to 2 micron, and a linearity of approximately plus minus 0.01%. The DP2240 and the DP2470 models support optional versions with red and blue laser light. The DP3000 series is a laser profiler series positioned higher than the DP2000 series. Firstly, the DP3000 series has an upgraded profile point counter of 3,200 points and a maximum detection frequency of 19 kHz. Secondly, thanks to the sensor support for single-frame HDR and the improvement of its photosensitivity characteristics, the DB3000 series has stronger detection capabilities for different scenes or materials. Finally, in the direction of ultra-high precision measurement, we released DP3020, covering an x-axis width of 11.5 to 14 millimeters, and achieving a z-axis repeat accuracy of 0.15 micron. The continuous increase in production capacities in the lithium battery industry has placed increasingly high demand on automation. 3D vision technology is mainly applied in battery cell production process, including detecting welding defects in the tap before it's sealed into the cell, measuring the size of the top cover weld seam, and detecting defects in the surrounding weld after the cell is sealed, measuring the size of the top cover, detecting the deviation of sealing nail after injection, detecting welding defects, and conducting a six-sided visual inspection of the appearance before assembling the battery pack. Taking the six-sided inspection of square shell lithium battery as an example, a series of defects such as scratch, dents, and bulges will all pose safety hazards to the subsequent use of battery. So quality inspection of the finished battery cell is essential. However, the specification of scratch is not easy to quantify, and the 3D imaging is easily affected by a scratch on the surface of the cell, making visual inspection highly prone to misjudgment, ultimately affecting the yield rate of a finished battery cell. Moreover, the encapsulation process of battery cell requires a high production rate, which poses great challenges for 3D visual inspection. To address the above challenges, we have adopted a solution that combines 3D vision with AI. Specifically, we use deep learning to train on the brightness image of the laser profiler and employ AI algorithms to identify the candidate areas with scratch. Furthermore, we map these areas to the depth image of the profile and calculate the depth of each scratch, enabling us to fill out the NG symbols that need to be detected. The innovative 3D plus AI approach effectively meets the requirement of the six-sided inspection of square lithium battery, achieving a detection effect with zero misdetection rate, low misjudgment rate, and high efficiency. In addition to battery six-phase inspection, our laser profiler has achieved good results in applications such as top cover size measurement, top cover explosion-proof valve flatness inspection, top cover weld seam inspection, and bus bar welding defect inspection, fully covering 3D applications for all processes in the lithium battery cell production. Let's look at the auto parts industry. 3D applications are mainly focused on precision devices measurement, pin detection, and seal inspection, all of which have been widely applied. Specifically, for the pin detection issues of pin sorting and the deformation problem of seal ring inspection, we have developed dedicated algorithms to reduce the difficulties of building solutions and improve the efficiency and the effectiveness of inspections. In 3C electronic industry, 3D vision has been widely used for a while, which is mainly focused on measuring flatness, coplanarity, gap width, and step height of consumer electronic products. This technology has played a key role in improving the quality of 3C electronic products. At last year's new product launch, I introduced to you the RGB-D stereo camera from Hikrobot. Today, I also bring you new development. Hikrobot RGB-D stereo camera has evolved into the speckle structure light stereo camera series for logistic applications and the laser gavel scanning camera series for workpiece applications. Let's take a look at the speckle structure light stereo camera. The camera projects speckle texture onto the object to be tested, and the image are captured simultaneously by two IR sensors. After binocular matching calculation, the depth map of the object on the test is obtained. The camera also has an RGB sensor, which can capture RGB images and the depth map of the object at the same time. Moreover, the RGB image and depth map are aligned on the coordinate axis and synchronized on the time axis, making them convenient for analysis and use. Let's review the DB500S and the DB1300A that were released last year. The DB500S is designed for conveyor belt application in the express delivery industry, used for various applications such as single-piece separation, grayscale removal, and robot packaging. The DB1300A, on the other hand, is specifically designed for warehousing and logistics, covering the pallet size of 1.2 meter times 1.2 meter times 1.8 meters, and mainly used for applications such as depolletizing and large volume measurement. This year, we will continue to launch the DB300S with a smaller field of view, mainly for the shorter working distance, as well as the DB700A with a field of view between the DB500S and the DB1300A. These four models form a complete product series. In the speckle structure light stereo camera series, the DB300S and the DB500S are intelligent models with built-in computing power, capable of building image segmentation and other functions, and they use deep learning frameworks with high algorithm robustness and good adaptability. The DB700A and the DB1300A, on the other hand, focus on high precision and improve the accuracy of depth acquisition through dynamic speckle and multi-frame fusion, thus obtain better quality depth maps in a large field of view. The laser gavel scanning camera series is specially developed for workpiece applications. Unlike the speckle camera projects speckle texture, the laser gavel scanning camera projects a set of laser lines and use the mirror to swing and scan the laser lines. Similar to speckle camera, the gavel camera also acquires a series of laser lines patterns through two IR sensors to generate a depth map, and synchronous capture an RGB image through an RGB sensor. Ultimately obtain synchronized and aligned RGB map. Thanks to this design, the projected energy of the laser lines is more concentrated, and the sub-pixel processing algorithm can be used to further improve the accuracy of laser line extraction, resulting in a z-axis repeat accuracy up to 10 micron for the laser gavel scanning camera. In addition, the camera adopts a high-width dynamic optic design, automatic exposure, multi-frame fusion, and other algorithms to further enhance the characteristics of anti-high reflection of metal surfaces and anti-environmental light interference, making it very suitable for obtaining 3D information of metal objects. The laser gavel scanning camera series is a product line that we are focused on. DLS 600P was introduced to you last year, which is designed to align with the material framework range, mainly for the application scenario of grasping workpiece in the material frame. DLS 1400P has the widest field of view, with a working range of 1.5 to 3.5 meters, which can effectively handle the grasping of large workpiece and the need of depolletizing. DLS 300P has a smaller field of view and mainly works at a distance of 0.4 to 0.8 meters, with a maximum coverage range of 0.6 times 0.46 meters, mainly used in assembly scenarios. DLS 200P has the smallest field of view and mainly works at a distance of 0.2 to 0.4 meters, with a maximum coverage range of 0.3 times 0.24 meters, mainly used for applications such as eye-in-hand, fastener locking, and high-precision measurement. The RGB-D stereo camera from Hikrobot has already served multiple industries such as warehousing and logistics, auto parts, mechanical manufacturing, and heavy industry, helping customers achieve automation transformation for robot applications. Finally, let's take a look at the mass production time of 3D vision products. DP2000 and DP3000 sub-series of laser profiler will be released in third quarter. For the speckle structure light stereo camera series and the laser gavel scanning camera series, these cameras will be released in fourth quarter. In addition, we will also release two complementary 3D software, VM3D and Robot Pilot. Both of them will be launched in 2024. Here is the entire content of our product launch event. Thank you for your attention. We will continue to work hard and bring you better products and services. Let's look forward to see you next time. Bye-bye.